All right, so we are going to look at a lesson for function notation, using it to evaluate. Let me go ahead and get my whiteboard up. All right, so let's talk a little bit about what our kids know at this point. I would say that at this point, our kids have done evaluating before. So they've been given equations and they've been told plug in 3 for x and evaluate.
And we're talking about like 9th graders or algebra 1.
Yeah, some are 8th, 9th grade. They're taking an algebra course right now. So where we want to get them to is where they can identify the difference in notation, that f of x is different than g of x and which one to use, and what it would mean when you have f of 3. And then if there's multiple x's, then being able to, plug in for multiple x's, not just one of them. And also knowing that f of 3 doesn't mean it's f times 3.
Right.
And kind of understanding that.
Yeah, common misconception.
Yeah. Which sometimes doesn't come out until we're solving equations. Like, or sometimes when they're evaluating, you see them all of a sudden at the end of the evaluating starting to divide. Like they've already solved equations in their past lives, and then they start dividing randomly at the very end, thinking they're getting itself or something. All right, so let's go ahead and begin. Where do you think would be a good starting place, like intro to these guys?
So I'd like to start with no variables and kind of do like a reminder on like order of operations.
Okay.
Yeah.
So then,
and just to get some of that misconception, or like just to trigger some memory back as to what they should be bringing with them from middle school.
So are we looking at a typical with everything in it kind of order of operations, or are we wanting to do?
I don't quite need the rigor of it. I just want to make sure that when they see multiplication, division, and addition, subtraction, that they're going left to right.
Okay. The other one I think of too is like when you have this kind of combo.
Yeah.
And which one you should do first.
Yeah.
Okay, so we're throwing in, and then we could have something like 3 times 4 divided by 2. And then throw on the other way around. 4 divided by 2 times 3, maybe.
And then I like to do one with addition and subtraction also.
So I always get stuck with the 2s, 3s, and 4s in my life when I'm coming up with examples. All right, so
I mean, we can stick with 2, 3s, and 4s. I like when I do things like thin slicing, or I like to call them problem strings. I like to kind of stick with some of the same numbers, because then students really see like how they relate to each other and how they can be used to help each other out.
Right. So 8 plus 4 minus. I'm making this way more complicated than it needs to be, but let's go minus 2. And then do subtraction first. Now, okay, so here's the other question. Do I go 8 minus 2 plus 4, so it ultimately ends up being the same problem? Or go 8 minus 4 plus 2, so we don't have that connection?
I don't know if it matters. Yeah.
Right. Okay, so we start with those.
Because I'm hoping that these are accessible to all my students, right? And this is kind of the first computational hurdle a lot of them have to jump over.
Right. All right, taking some notes quick. Okay, so how do we introduce function notation?
Oh, we haven't introduced function notation at this point. Like they haven't seen it as like a linear function, like f of x.
I don't know.
Because I typically don't introduce function notation until after they've seen it as a function.
So
like,
tell me more about that. What do you do?
so we talk about what an equation is compared to what a function is, because they think it's all equations, right? Because they see an equal sign.
Mm-hmm.
And then when they see the f of x, they also think multiplication. So then we talk about like, this is where we mean it's a function, and function is a special relationship. And the reason why we use it is because we want to show everybody that this is a one-to-one relationship.
Right.
You know, and so that's where they get to the introduction to function notation.
Mhm.
And then, so we do like that whole linear function unit before we start talking about like using the function notation to evaluate or to find specific points.
Okay. Okay.
Mhm.
And I've gone with, I introduced the functions. Usually at this point, I've introduced graphs as functions.
Mhm.
And so then they visually identify, we work on visually identifying like where is f of 1 kind of thing.
Mm.
But I guess I don't do it after we do linear functions itself. Okay, so they've seen f of x as a function.
I mean, we can also do what they haven't seen it as function, I guess. Like, I don't know. I
Well,
don't
even
currently teach ninth graders, so I think if we go with what the order you typically teach it. I haven't
well,
done
okay,
it.
so at this point they've seen f of x. They've seen it in place of y.
Mhm.
But not necessarily. I don't know that that's really my focus there as I've introduced it. So I'm trying to remember my introduction here. So yeah, so I've mainly gone with, this is f of x, and then we try to find f of 1. And we talk about where
Hopefully
is
they know
that,
to
and
look for.
that this is my independent,
Mhm.
and then they'll find the dependent.
Just using the graph and estimating.
Yeah, it's a way better graph than what I just showed.
So then I wonder if, okay, so then once we do the order of operations, I wonder if your students already know f of 1, you go back to here. Start with your graph and say, okay, we're going to estimate where f of 1 is, f of 2 is, f of 3 is,
Mhm.
And then give them the equation and say, how do you think we could find f of 1 if you know the equation?
Mhm.
The equation is the graph, like.
Right, so do a couple review. That on the graph.
Mhm.
So then I wonder if I specifically pick one that we actually use the graph and then we move on to the equation, that exact equation.
Yeah.
So let's say let's use just a quadratic maybe.
Sure.
Just so it's a little more interesting than a linear. Or do you think I should go?
I like linear to start because that's a predictable pattern for them. Because then we can say, so if they can estimate where f of 1 is, f of 2, and f of 3 is, could we get them to guess where f of 4 is? Or f of 12, whatever it is, that's maybe not on the graph. And then we can show the equation and say, okay, if we know f of 1, how do we get from the equation f of 2, f of 3? We had the graph to also prove that. right?
All right.
Visually. And then how does the equation help us knowing that our f of 12 is correct?
We have a stylus. This is not that easy without one. So let's just say we have this basic one here. Okay, so we start by, and so this would be review at this point. And so start by giving them this graph and just ask for finding f of, let's just go 1.
Yeah. Okay. You can literally go 1, 2, 3.
Right.
You know, so they can see their pattern.
Okay.
And then we can say, okay, now we're using what you know, can you do f of 12? You know, something I like to give something that they can't just
They can't follow
6.
the graph.
Yeah, he did 6, they could easily just
Right. So if we went to f of 12. Okay, so at this point, f of 1, they're going to tell me 4. F of 2, they're going to tell me 5. F of 3, they're going to tell me 6.
so if they have to, they can mentally count. Yeah.
Okay, so what's our transition going to be for the equation? Or is it just saying now, you know, that was tough. That was a bit more challenging than the one, you know, because it went off the graph. So here's the equation.
So then I would say, this is the equation that matches our function. The equation of the function, I should say. How do you think we could get 4? If f of 1 equals 4, how do you think we can get 4 from here?
Okay. I like it.
You know, because some students might already see, oh, I can see it's 1 plus 3, 2 plus 3, 3 plus 3. You know, and so when they see the function equation, it may not surprise them.
Right.
But we're gonna have students who are gonna still feel a little confused about like, okay, how did we get 4, 5, and 6 without the equation?
So they've gone from the, I'm taking notes off to the side here, sorry.
No,
So
you're fine.
they've 1, 2, and 3, they've used the graph and gotten that. We asked for 12. They may or may not have come up with an answer for that. And then we say, okay, so here's the function equation for that graph. What do you think we would do to find f of 1?
Just before we go on, is function equation, is that the correct terminology?
Probably not.
Because I'm like, I don't think so. But again, I feel like I haven't taught this course. You know, I've taught it to like 8th graders.
Right.
In a couple of years since I've taught this course. But whatever.
So this is the function. This is the function rule. Sorry, function rule, I think is the
There you go. Yeah, I think
correct terminology. Function rule. So then how do you think we would find f of 1? And then do you think we go f of 2?
Yep.
F of
So we
3?
want them to correlate. Well, yeah.
Right, with the graph.
You'll see the graph and those answers. F of 1 equals 4, F of 2 equals 5.
Right.
We want those answers the same. And then we still go to F of 12. And then we don't come up with an answer yet. We just say, okay, if you can find a relationship, we're going to do another one. Does that relationship or does that rule, whatever it is you came up with, still exist with this new function? And we can still do linear. I would do another linear one. Perhaps just go negative.
Right. So then our little change is going to be changing it to a negative slope, maybe. Do Do you think going a negative fractional slope would be too much?
Mm-hmm.
So just a negative slope.
Yeah. Because we still want them to be able to like predict something that they're not going to be able to see on the graph. Because if you go, even like a negative half is too big of a jump for some students. But if we just do like negative x, we can do negative x minus 2, like that. If you wanted a little bit bigger jump, if you want a smaller one, you can do a negative x plus 2.
So let's see here. So we go now. Let's do a negative x plus 2.
Yeah, because that's a smaller slice versus minus 2. My students are always more comfortable adding with integers than they are with subtracting integers, and I feel like it's true across the board.
So then
we give them, we do the same thing with f of 1, f of 2, f of 3, f of 12. And I like to repeat things because they already kind of maybe have an idea how f of 1, 2, 3, 12 work for one function. I want them to apply again for a second function.
they're same ones again.
Mm-hmm.
And then,
But then this time I would also immediately give them the equation f of
okay.
x. Yeah.
But at the same time, be able to make.
Mm-hmm. And say what you were thinking about how all of this relate together. Is it true for this one also?
Mm-hmm.
Any relationship, anything that you thought was true over there, is it true here? Yeah. And then if you want to, your next could be a fractional slope. Or if you were feeling like your students are confident, you can jump to a quadratic, but an easier quadratic, like an x squared plus 1.
Right. So that's going to be a big like check on your students and where are they.
Mm-hmm.
It's probably depending too if you're doing 8th grade versus 9th grade.
Right. And if you have both problems ready, you can go determine it by group too, you know.
Mm-hmm.
Like one table may be ready for the quadratic and one group may not be ready for the quadratic.
Right. So we could now have 2 separate paths.
Mm-hmm.
We could have a group that goes 1/2 x plus 4, and we could have a group that goes x squared plus 2.
Yeah, so maybe with the linear function half x plus 4, I would also go with just even values for x's.
So then just f of 2,
Mm-hmm.
4.
Mm-hmm.
Right. Yeah, I agree. Because then we're not gumming it all up with fraction
Right.
insecurities and things.
Right. And you're still just trying to build that confidence. And half is a fairly comfortable fraction for most students because they can take a number in half.
Mm-hmm.
But they're less likely to see the pattern or to connect all the true statements when they start seeing fractional answers.
Right.
Whereas your quadratic, you can choose whatever. So like for this slice, they can choose whatever path they want to choose, but you're still giving them the value for x to use.
Right. So that's an interesting. At what point do you think you start changing off to g of x and h of x?
I would do one more that's f of x. but not give them values of X and say, can you come up with what your function looks like? Like, do they do the reverse now? Given the function, can they draw the graph? You know, like, are they realizing that we're pulling our X values from the graph or from points?
Right. I feel like that makes more of a stronger connection between the two, having changed directions. So then, do you think stay linear on that one?
Yeah. Then yeah, we can go back to linear. Or for the students who went to the quadratic, can go back to linear.
Right.
So yeah, so this time they don't get values. They have to make their own values, find their own values and make the graph. So how do we use this function to create a graph from it?
Right. So if we did, do you think it'd be too much a jump to say like negative 2x plus 5?
The +5, yes. +1, no.
You think plus 5 is too much of a jump?
+1 would be not as bad, but how thin are we slicing this?
I'm just thinking like the 9th graders, they've gone through 8th grade algebra. So is 5?
I think the bigger number just makes it difficult. The rigor is already there with the function notation and getting them to connect it with the graph,
Okay.
coming up with their own values. But it does, I don't think, yeah, it doesn't make it more, it just makes it difficult, like computational wise, that's it.
But again, they're in groups though. So like I feel like
I mean, I'm like, I don't oppose it.
I'm just thinking I kind of want to push them.
Yeah.
I kind of want to push them. They're in groups, so they should have someone in there to be able to support them if someone's feeling off, and then they can look around a little bit if they need to.
I mean, some of the hope is that when they see the function, like if you look back at your graph, the negative x plus 2, is that they're like, oh, I see the +2, that's my y-intercept. You know, that's kind of the hope, some of the connections you hope they're making without us saying anything.
Right. But then again, that's focusing on the linear part of it where.
Right, but those are things that are going to make them feel more confident as to how they came up with answers. It's like, I know these different parts of my linear functions. I'm seeing it here play out too.
Right. Okay, so then let's say we start with the changing of f of x to g of x.
So yeah, so then this is, we could jump to like, okay, now here's something you haven't seen. You've seen a bunch of these f of x now. Let's go to g of x.
Right. So let's say I give g of x equals make it bigger. Okay, and then do I just go straight to, you know, like let's find g of 2? But now we're assuming they've figured out that they can plug in, that we're just kind of trying it out and seeing if that.
Well, even if they haven't, the question would be like, can you apply what we just did here?
Right. Right. What would you do?
And so they plug it in, right? X squared is 5, they're gonna get 9. How do we, well, then how do we know? How do they check themselves? Are they gonna graph x squared plus 5 on like Desmos?
I mean, they could.
And then find that point, you know?
They could. Or it could be a teacher check as we go around. Check around the room, looking at each other's boards, seeing if everybody else got the same thing. I'm kind of curious too, if we start, and maybe this is too big of a jump.
I think they'll be okay.
Because I mean, we're jumping to the different notation with G and then H. And then now it's also checking to see if they realize they need to plug it into both of them.
Mhm. I mean, if we're talking about even 8th graders, they know how to evaluate expressions given like x equals 5, x equals 2,
Right.
or even when there's multiple different variables. I mean, they know that, like, wherever I see A, I'm gonna use that value for A. Wherever I see B, that's the value I'm gonna use for B.
Okay. So then do you think there's a point that we can take and give them like a group of functions all with different letters and just start asking them to find f of 1, g of 5, h of 7? Or how do we play that different letter naming the different function?
This is where I don't know if we want to give them. So okay, so they're successful with g of x, they're successful with h of x. I think this is where you can end it and have a whole class discussion about
Consolidate at this point?
G and H, yeah.
Okay.
Or if you really want to, you can give them an algebra 2 problem and do f of g of x, but real simple.
Right. Right.
So for like the groups that are like clearly moved on and are like really getting it, that's the next challenge before you're ready to bring a whole group together. But
Okay.
or
I
even
like it.
or even just g of y equals x squared plus 5, like what do I do?
Yeah, what do you do?
Yeah. But I mean, that's just based on like, your class, or the group, or
Right. Right. Okay. So consolidate, and then it'd probably be a good time to take notes and work on individual problems and make sure they can do it on their own. I like it. All right. Thank you for your help.
Yeah. If anything, if you're feeling like there's a big jump there, and like some of the problems we did skip was evaluating expressions. Like if you want to skip the order of operations and do evaluating expressions and then go into this, you could do that, or have it all: order of operations, evaluate expressions, and then function notation.
Right. That's a good point too. Yeah. Yeah. Because we didn't do that. We didn't. And I think sometimes that's what I've done is I've done, here's an equation, here's, no, not even that, an expression. So just x plus 5. And I say, what if x equaled 3? What would you get? And then I just talk about more sophisticated knowledge, but I feel like I'm handing it to them too much there. So I kind of like from the graph and comparing your answer from the graph to the answer from, the function rule, and what can you do with that?
And I think that's something like we as teachers need to do more often for them, is just to say, your function is a graph. Your graph is a function.
Right. Right.
And we don't do that enough. They don't see together enough, except for when they have to like plot your function.
Yeah.
But even then, like evaluating the expression, they've done it since like 5th grade.
Right.
As long as teachers are following standards and teaching standards, they've done it since like 5th grade. So,
right.
But again, I like to start with successful things that they will hopefully be like, okay, we remember doing this.
Right. Very nice. All right, I'm going to end the recording. Maybe I can remember how.
I think you just go back to the record button, don't you?
Recording right